Okay, so we're going to take a look at skill 4, which we're circling back to this idea of finding a max and min on a given interval of a function. We're just going to focus in on functions that need these new derivative rules we have, product, chain, and quotient. So to see how that looks. So just as a recap, we're going to find all critical values of the function. And critical values for us are going to be where the derivative is 0, where the derivative does not exist, and any points, and our two endpoints, sorry. So anywhere where any of those three things are happening, those are going to be what we're going to consider critical values. And then plug them into the original function and see which one's the biggest, which one's the smallest. So with that, you're welcome to pause the video here, work through the first one, because we have done this. If you're pretty sure you get to the right answer, you can kind of skip to the video and make sure you've got the right answer, and then do the same sort of thing with the next one. If you want help with the specific factoring or derivatives, then watch the whole video through. So I'll get going on the first one. We're going to need the chain rule for this. So the 4 is going to come down, become a 3. And then the chain rule says multiply by the derivative of what's inside. So there we have it. So what I would do from here, we're going to want this factored. So I would factor the inside bracket now. And then probably if I wanted that looking as nice as possible, I'd pass the power of 3 onto both of those pieces. So there we have it. I normally start with this, but our critical values, we get 1 and 4 for free. We get x equals 0, which we're not going to consider, it's outside our range. X equals 3. And x equals 3 over 2 or 1.5, however you want to handle it. So 1.5 and 3 are definitely on that range, so those are the 4 values that we're going to have to consider. So we're going to do f at 1, which is going to be 1 minus 3, so negative 2 to the power of 4, which is positive 16. F at 1.5, I'm actually going to plug into my calculator. I get 25.6 there. F at 3, let's see, you're going to get 9 minus 9 on the inside, so that's going to be 0 to the power of 4. And f at 4 is going to be 16 minus 12, so 4 to the power of 4, which is 256. So there's our max. There's our min. So there's the first one done. We can move on to the next one. So we'll write down the 2 that we get for free. This one, we've got 2 things multiplied, so we're going to need product rule. It's just F. So there's our different parts. So the 3 comes down, becomes a 2, then multiply by the derivative of what's inside. So that's 1 for g. Now we're going to do our product rule formula, f prime g plus g primed f. So there's that. And before I think about simplifying anything or expanding anything, I'm going to always look for common factors first. So we have x plus 1 to the 3, x plus 1 to the 2. So I can factor out x plus 1 to the 2 and then see what's left over. So I get that from the first piece, that from the second piece, and now that's much easier to clean up. So we're going to get 5x squared when I expand everything and combine my like terms. I'm going to get 2x, and I'm going to get minus 12. So from there, I try and factor that, and it won't factor, and I remember it doesn't factor because I'm actually recording this for the second time, because the first time I was speaking into a headset that was not plugged in. So hoping this is the last time I have to do this question, but we'll see. So for this piece, we're going to get our critical values from the quadratic formula. So bear with me as I plug this in. And we get 1.36 or negative 1.76. And let's not forget we also have x equals negative 1 from that first term that we factored out. And lucky us, all of those are on our list, or in our interval. So I wasn't very nice when I set this one up because we have 5 values to plug in. But luckily, the two endpoints, if you look at that first bracket, the two endpoints will make the overall function 0. So really, we just have the other ones to plug in. And I am going to cheat on this and switch over to Desmos and look at the picture there. So those are our two endpoints at 0, like I already said. When you get negative 1.76, when you plug that in, you get 0.4. That looks like the max to me. We get 0 at negative 1. I think that was our other one. And we get negative 28.2. So that looks negative 28.3 when you round. So that looks like the min at 1.36, and it looks like the max at negative 1.76 should be your final answer there. So you can, hopefully you have that written out already. I'm just going to jump to the next one. So here we're going to need quotient rule. So I will cordon off some area on my screen for this one. So keep in mind that we're going to plug in the n values as our critical values for this one. So quotient rule, f prime g minus g primed f all over g squared. Just to save myself some room, I'm going to attempt to get this all in one go. So f prime is going to be 2x plus 4. G is x minus 4 to the power of 2. And then plus for g prime, the 2 comes down, becomes a 1. And then you're multiplying by the derivative of what's inside, which is just 1. So it's just 2 times x minus 4. There's f. And then we're doing over g squared. So you multiply the two exponents, and you get a power of 4 there. Same sort of idea. I'm not going to go too far before I look for this common factor, which we do have one. It's the x minus 4. So I'm going to common factor that out. be left with 2x plus 4 from the first term and one of the x minus 4s. And then, no, this is minus g prime. Minus g prime. So that's what I have left over after I common factor. That's weird because this is a stylus, but I still scribbled on the screen to make it work again, like a pen that was dying. Okay, so we have that. One of these is going to cancel out one of those and become a 3 on the bottom, and then we don't have to worry about that on top. And then we're going to expand the top. So we're going to get 2x squared, we're going to get minus 8x, but then a plus 4, so minus 4x. And then a minus 4 and a plus 4 is going to make minus 16. And then I'll multiply the negative 2 by through the second bracket. So we have that now. And this one's really nice because those cancel out. And so we're just left with negative 12x minus 12 all over x minus 4 to the power of 3. I like to factor out that negative 12 so that I see that I get x equals 4. And x equals 4 would be a critical value. It's not inside our range of minus 5 to 1, so we don't have to consider it. It's really nice that we don't have to consider it when we're looking for a maximum value, because it is, in fact, a vertical asymptote on the original. So on this type of question, I'll always not have that on the interval, because you can't really find a max or a min if there's a vertical asymptote. Well, you might be able to find one and not the other, but I won't ever make you deal with that. So that one's outside our interval. The top, we get negative 1 as the other critical value. So again, we're plugging in these 3 values. Again, I'm going to cheat and go to the Desmos graph. No, I've already got them clicked. So you can see the values you should get. So it looks like a max at 1 and a min at negative 1 is what your final answer should be. So you should get that when you plug in those 3 values. So there you go. So that's skill 4. You can take a swing at the exit card, and we'll take that up in class. And then you'll move on to skill 5. And we'll do the practice for these 2 skills in class.